All right, well, we're going to talk in this section about compound inequalities, but before we do that, we need to talk about the concept of and or, because this is going to be crucial to understanding how we're getting our answers with these compound inequalities. So let's put this in some terms that hopefully we can understand a little bit better. Let's talk about, let's say that, I'm out driving around, and for those of you who are not close to Tulsa and, may not know where we're at, my campus is located next to Sand Springs, so I'm using some streets near Sand Springs, Oklahoma to kind of get an idea of where we're at. But I think you'll get the concept anyway. So I'm driving around in Sand Springs, and let's say that my car breaks down and I need to call you for help. If I tell you that I'm at Highway 97 and 41st Street, then would you be able to find me? Well, hopefully, especially if you're familiar with the area, because we would know that Highway 97 would run a certain direction. Actually, it runs north and south, and 41st Street is a street that runs east and west. So if I said that I'm at Highway 97 and 41st Street, then you would know that I'm right here at this one particular place. You could drive to that point and come and find me very easily. Now, what if I call you and I say, well, you know what? I'm on Highway 97 or I'm on 41st Street. Well, now this is a whole different situation, right? Because if Highway 97 runs north and south, I could be anywhere along here. If 41st Street runs east and west, I could be anywhere along here. If I'm sitting right here at this spot and I tell you that I'm on Highway 97 or 41st Street, I'm telling you the truth. I just happen to be on 41st Street. So when we say or and, it makes a huge difference in what we're talking about. When we say and, we're talking about the intersection of these two things. When we say or, we're talking about the union of them. So and equals an intersection, and or is a union. Now we're going to talk about what that means. So let's talk about it with sets, and let's see if we can make some sense about it, okay? Let's say that we have these two sets of things. We have set A that contains these elements: 1, 3, 5, 7, and 9. Remember, elements are things within a set. B has elements 1, 2, 3, 4, and 5. So here again, we want to know what are the things that are in set A and also in set B. Well, in set A and B, they both have a 1, don't they? So 1 is in both of them. They also have a 3 in both of them. And they also have a 5 in both of them. This is where they intersect, just like in our example where Highway 97 and 41st Street was the intersection of those two. So we're talking about what these things have in common, or where they meet. If I say what are the things that are in set A or in set B, now we're talking about everything that's in them joined together. So that would be a set that would have 1, 2, 3, 4, 5, 7, and 9. As long as it's in one set or the other, it's in the or the union of them.